So, Grace, good yawn. Last day, we said we can handle two-dimensional motion if we break things up into components, horizontal and vertical. Our key ideas were horizontally, the acceleration was 0. Vertically, the acceleration was negative 9.8. In fact, I said my way of keeping things separate was to use a T table. That vertical line down the middle of my page helped me realize don't put horizontals into vertical, don't put verticals into horizontal equations. I told you that there were going to be three main situations we were going to look at. We looked at horizontally from a cliff. That one was the easiest because when you were launched horizontally from a cliff, your initial vertical velocity, Vy initial, was 0, and that makes equations nicer anytime something is a 0. Then we did ground at an angle. Did I say angle? Components. We broke it into components. It was a little bit tougher, but we had some advantages because it was symmetrical, because we were starting on the ground and ending on the ground. We could say things like, oh, find the time to top and double it. There's my total time of flight. The toughest is combining those two from a cliff, but not horizontally, at an angle components. But let's do a little bit of review. When we launch an object into the air, we call it a projectile. Projectiles travel in a parabolic trajectory, but it's easier to use vectors. We can break each projectile's velocity into vertical and horizontal components. So example 1 says, break the following velocity vector into its horizontal and vertical components. I'll probably throw a question like that on your test, and I'm hoping it's almost free marks. It's, okay, draw a little dotted line, there's Vx, there's Vy. Normally, I would label that Vy initial just to remind myself that that's the one that's changing. I would go color, 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 color. I would label my sides. The 24 is definitely the hypotenuse. What's Vy, opposite or adjacent? Opposite. What's Vx? Adjacent. So if I'm finding Vx, which trig function am I going to use? A and H. Which one is that? Cosine? So it's going to be cos theta, I'm doing a generalized version, equals Vx over 24. So if you want me to find what Vx is, it's going to be 24 times the cosine of 36 in this case, and I get 19.41, If they just asked me to report the answer, I'd go to 3 sig figs, 19.4. If I was doing something with this, Davis, I would carry some extra sig figs somewhere just so I'm not rounding off willy-nilly. Davis, which trig function can I use for Vy initial? You don't say. So you're saying the sine of my angle equals Vy initial over 24? And I could have just backspaced and edited if I was really, really clever. And I get 14.1. And again, Sam, if I was going to use this, I would carry some extra sig figs. I should put units on my answers, though, because Mr. Dewick, of course, final answer should always have units. Jack, what trig function was Vy? Vy? It's not sin. It's only a sin when you call it sin. Say it again. What trig function is Vy? What trig function is Vx? If you always have the angle next to the horizontal line, which you will for a projectile, Vy will always be sine, and Vx will always be cos. Mr. Dewick, yes, Owen, do you have a stupid way that we could remember that Vy is sine? Mr. Dewick, is there a dumb way that I could remember that Vy is sine? I got nothing. You'll have to come up with something on your own. Mr. Dewick, is there a dumb way that I can remember that Vx is cosine? Well, of course there is. If you're looking for a stupid hook, you can do the trig each time, and that's also fine, Grace. But as long as you're giving me the Vx and Vy angle from a horizontal, and I can't think of a time that I wouldn't, then if you're looking for a dumb shortcut, Vy will be sine, not sin, sine, and Vx will be of cosinus. Take it if you want. Boy, yeah, blow that punchline there. So I kind of tried to break things up. Here's kind of a little summary. If you're looking when you're studying for your test at stuff you should know, it would be this. So horizontal motion, Vx is constant because Ax is 0. Or Ax is 0, which means that Vx is constant. That means that d equals Vit plus a half At squared just becomes dx equals Vxt. That means if you know the time of flight, you can find the horizontal distance, or if you know, also called the range, or if you know the range, if they give you the horizontal distance, then time is just dx over Vx. No quadratic, no square rooting, no, much nicer. Okay. I think I said to you last day that most of the time we're going to spend our time finding time. So vertical motion is trickier. Vy changes. Ay is a constant. It's negative 9.8 here on the Earth. So dy equals Vy initial t plus a half Ay t squared. Now, if we're lucky, if we're launched horizontally from a cliff, then we can do that. But most of the time, we're not going to be launched horizontally from a cliff. We're going to be launched at an angle. At the top of its arc, Vy is 0. Does this mean that the total velocity is 0 at the top of its arc? No. There is still Vx, right? But it does mean if they ever ask me, hey, what's the total velocity at the top of the arc? Oh, just find what Vx is and you're done. That's what the velocity is for that split second right there. Everywhere else, you'd be adding the two components together using Pythagoras to find the velocity at that location. If we start from ground level and end at ground level, then we can say that the initial vertical equals the final vertical, but negative. That's handy. Can we say that if we start on a cliff, though? If we start on a cliff, will the initial vertical velocity be the same as the final vertical? No, in fact, I can tell you this will have a much bigger magnitude. We're going to hit the ground harder. Is that okay, Emma? Last, if you're starting from a vertical height, from a cliff, the ground is below you, which means your vertical displacement needs to be negative. It means if they give you the height of a cliff, when you use it, you'll have to put a negative in front of it. Or if you're solving for the height of a cliff, you'll get a negative answer because what you're actually solving for is the displacement. Technically, that's the whole lesson and I'm done. I should be able to give you the homework, but I'm going to just look at some examples. Hopefully, you don't learn anything new today. You are going to want your calculator handy, maybe your formula sheet, but if you've memorized d equals Vit plus a half At squared and Vf squared equals Vi squared plus 2Ad and Vf equals Vi plus At, then you're good. Oh, I had somebody ask me this a couple of years ago. They said, Mr. Dewick, you're saying catch, 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 catch. Back, 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 back. You're saying these projectiles travel in parabolas, but I've seen some that seem to wobble in the air. Have you ever seen something thrown that seemed to wobble in the air? That's a good point. Put your pencils down, look up. Projectiles from cliffs at angles. There is going to be one of these on your test. This will be the longest in terms of number of steps question. There's several strategies. One way you could do this would be to find the time to the top. Then, starting at the top, find the time all the way to the bottom, and then add those two together. Meh. Doable, but meh. A second strategy, Petco, to find the time of flight would be to do it all at once. I'm lazy. If I can do it in one step, I'm going to do it in one step. Even if it's a more tough procedure, I'm going to do it in one step. Third strategy would be to find the time to top, double it to get the time back down to the cliff, and then find how much time it takes from there down to the bottom. Don't recommend that. And honestly, I don't really recommend that. If you can handle the quadratic formula or you have a quadratic solver, strategy 2 is our best bet. If you can't handle the quadratic formula, or if you're shaky on the quadratic formula, see me during a blended and I can show you a workaround that doesn't require the quadratic formula, and you can still do strategy 2, finding the total time of flight. Let's do one. I like example 1. I like example 1. Example 1 is a nice question. Okay. Looking at the picture here, Marcella, is there a cliff? Yeah. Is there an angle? Did I say angle? We're going to break this into components before we even start. We are going to do a T table, but before we do that, we have to break this into components. And so I'm going to go like this. Here's Vx. Here's Vy initial. Why did I put an initial on the Vy, but why didn't I bother putting an initial on the Vx? Isn't Vx V initial too, technically? I'm just reminding myself that only one of these has an acceleration that's going to make the velocity change. Okay. I could do the full trig, color, but Jack, Vy, which trig function is that going to end up being? Vy. Oh, come on, you knew I was coming back at you. Help them out, folks.
Sine.
What?
Sine.
So it turns out Vy initial is going to be 50 sine 30. Jack, which trig function is Vx going to be? Not sine, but of course it is. And again, you can do the trig, but if you want that stupid memory trick, you could add that to your purple sheet if you're desperate, but it's handy enough that my students have said they're good with it. So I know sine 30 is exactly 0.5, so Vy initial is 25, bang on, right? Vx, I know cos 30 is 0.866 times 50. Can I do that? No, I need a calculator. Caught up with us now? Ready to go? Awesome. I'll go 40.3013. 40. Well, you know what? 40.301. 5 sig figs. Not 43. 40.3. Is that right? 43. Geez, I wrote it wrong twice. 43.301. Generally, if I go 5 or 6 sig figs, I'll get 3 in my final answer sig figs of accuracy. So round off to somewhere convenient and carry some extra digits. Now, is this a projectile? T table. I'm going to do my T table right here. Horizontal, vertical. What are my 2 physics no-brainers? Oh, AX equals AY equals. And then I have 2 more things. I can say Vy initial is 25. That goes in the vertical column. Vx is 43.301. That goes in the horizontal column. Well, I have 2 things in the horizontal, 2 things in the vertical. I need 3 things to find the 4th. What else do I know? Oh, dy. And what's dy? Careful. Negative 60. Negative 60. Harsh, which column do I know 3 things in? I'm going to solve this vertically. So I'm going to make a little t equals question mark. I'm looking for an equation that has an a v, a d, and a t in it. There is one and only one. Which one? Mentioned which equation? And I'm going to be really meticulous, Manchand. I'm going to put a y there, and just to remind myself, don't put, by the way, the most common mistake, kids want to put the 50 in for the velocity because that is the starting velocity, and it's a nice round number with no decimals. Oh, that's so much nice. No, vertical. Even if it's a yucky decimal, that's what's going to go there. What kind of an equation is this? It's a quadratic. How do I know? What makes a quadratic a quadratic? It's got a squared. And unlike Physics 11, where I always made sure that one of the t's would cancel, nuh-uh. This is a full-bore quadratic. Our equation is going to look like this. Negative 60 equals 25t minus 4.9 t squared. I was bad and I went half of negative 9.8 in my head. How do I solve this? What's step 0 before I even begin? Make it equal to 0. Step 0 is make it equal to 0. Yeah, I could plus the 60 over. I'm going to move those two over. I'm going to write it as positive 4.9 t squared, take away 25t, and the negative 60 just drops down like a domino. That equals 0. How many of you have a quadratic solver? Go ahead. Those of us that do not, time for the quadratic formula, which is also on our formula sheet on the back page. It's going to be t equals negative b plus or minus the square root of b squared minus 4ac all over 2a. I'll make a little note in my equation. That's a, that's b, that's c. B is negative 25, so what would negative 25 be? 25 plus or minus the square root of negative 25 squared minus 4 times 4.9 times negative 60 all over 4.9 times 2, which I'm pretty sure is 9.8. I've done that one a few times. Do you have the built-in solver? Yeah. Oh, lucky you. So you've already got T. If you have the solver, use your solver, get T so that we have a confirmation, and also for practice. And if you've forgotten how to use your solver, let me know and I'll walk you through it again. I'm going to try doing this in one step. So, is this a fraction? Yeah. Brackets around the top. 25 plus square root, open up a bracket. It's negative 25 squared. Emily, when I square a negative, what's a negative squared? Does it stick around or does it vanish when I square a negative? So I'm not even going to bother typing the negative in front of I'm just going to go 25 squared because I know that's the same as negative 25 all squared, and it's less typing. Minus 4 times a times c. Close off the square root. Close off the top. Divided by 9.8. Is one of your answers 6.88144799.5? I'll go 6.8814. Is that right? If I backspace and put the negative in, those of you with your solvers, your other root is negative 1.7794. That, and that one, reject, right? Like Sam trying to dunk, reject. What do they want me to find? Oh, that's the flight time. 6.88 seconds. Is there a part B on the next page? I think there is. Ah. Find the range. You'll notice I left you like a half page to find the flight time. I barely left you any room to find the range. Why is that? And no plus a half AT squared. By the way, can you see how tempting it is to put in the 9.8 in for the acceleration and the horizontal? Because, oh, there's no acceleration, I must put something there. No, there is an acceleration. It's exactly 0, which is a nice number to do math with. What was Vx? It was 80 something, 43.301 times, I'm going to write 6.88, but all of you know I'm using my answer button. In fact, if I really wanted to be meticulous, instead of using 43.301, I could type 50 cos 30 times answer button. I'm not going to. Is that a hand up? Good. Don't clear your calculator. I'll be there in a second. Oh, I got the wrong answer button. Shoot. So there's my answer button. 43.301 times answer button. I had the wrong answer for a second there. 298 units meters. You figured it out okay? What was it? There you go. Yeah, and by the way, what you're realizing, I'm going to say, and this is going to sound weird, none of this is very tough. The problem, Jack, is it's about 40 steps of typing. Is there room to make a mistake? Yeah. Be meticulous and careful, which is why I'm trying to give you all these stupid little, watch for this, watch for this. Here's a dumb memory trick to remember this. Is that okay so far? Cool. Kyle, what does C want me to find? Oh, can't I just go 6.88 divided by 2? Or can I? Why doesn't that work this time? It's not symmetrical, right? I fell for a lot longer than I went up. So I'm going to have to, I can't use my answer for total flight time. That doesn't help me with anything about the top. So we're going to start over. But Kyle, top, does that imply vertical or horizontal, the word top? We're going to solve this vertically. So they want me to find T, I'll change colors. T top. I can still use my initial vertical velocity of 25. I can still use A equals negative 9.8. That's only 2 things. I need 3 things to find the 4th. What else do I know? What's Vy final at the top for a split second? And again, if you can't get that from here, Percy, can you see the temptation for some kids would be, I'll put a 25, Vy, I'll put the 50, the slanty there. I got to put something there, right? Be careful. Be meticulous. Don't panic. I'm looking for an equation that's got a Vi, a V. Oh, this is Vf equals Vi plus At, isn't it? Get the T by itself. It's going to be T equals Vf minus Vi over A. Make sure all of those are vertical values. So if you wanted to, you could put a Y there, a Y there, and a Y there just to remind you. It's going to be 0 minus 25 divided by negative 9.8. And I get 2.55 seconds. And I guess now, Kyle, I could argue since the total flight time was 6.88 and it took 2.55 seconds to get to the top, it must have taken 4.33 seconds to fall all the way back down to the ground at the base of the cliff. I've never bothered asking that question, but I've just decided that might be a nice one to throw on a future test. It like a nice little follow-up. Ooh. Oh, you left me a lot of room for D, Mr. Dewitt. This must be a trickier question. Kai, what does D want me to find? What is the answer not? Zero. Not 0. Okay. Question, Matt? Okay, you figured it out okay? You back? Good. This is probably the most difficult of all these questions. D. I would consider D fair game as a nasty multiple choice. It's difficult enough that I might not even be comfortable doing it as a written because it's so many steps to get there. Okay. Really, Mr. Duke? Yeah. So it says D, find the impact velocity. Here's my first argument. I think I can DALP. I think the impact velocity is going to look like that. It might be a bit steeper. It might be a bit shallower, but I'm telling you, it's going to come in at an angle. Did I say angle? Okay, got the argument. So my first thing that I would do, Matt, is I would say, well, it's going to hit the ground at an angle, which means I can break it up into a horizontal and a vertical, although this Vy is Vy final on impact. Hey! I know this one. What's Vx? Sorry? No, you use the slanty. How dare you? We're never using the slanty. Evil, evil. Blah. What's Vx? Horizontal. I'll bet you it's in your T table, cleverly written down somewhere, labeled as Vx. And by the way, I'm glad you made that mistake because that's a common mistake. What is it? 43.301. It's traveling sideways at that speed the whole time, trucking along. However, this one, Vy final, how fast it's traveling vertically right when it hits the ground, I'm going to have to calculate. How fast it's traveling what? Vertically. Oh. What do I know vertically? I know Vy initial was 25. I know A was negative 9.8. Oh. I know dy was negative what? 60? It's in your chart. Is it negative 60? I don't care. The physics takes care of that. All I know, look, so Matt, you asked a good question, but first of all, is that statement there correct? Is my initial velocity positive 25 vertically? Yes. Is gravity at negative 9 point? Yes. Is my displacement, which takes into account the change in position, negative 60? Yes. Then I'm good. I can find Vy final because I've got three things. I can find a fourth. I'm looking for an equation that has a Vi, an A, a D, and a Vf in it. There is one. Which one? I heard someone whisper square root. Which can you someone tell me the original equation first of all? And to get rid of the squared, I'll just end up square rooting my right-hand side once I'm done. Yeah. So V final is going to be the square, Vy final is going to be the square root of 25 squared plus 2 times negative 9.8 times negative 60. Is the answer 42.438? No, that can't be right. Why must that be wrong? Huh? Someone said it. They were right. Okay, we have to add the negative because we know it's going down. Our calculator will always assume when we take the square root of any number, our calculator is programmed to assume we want the positive value. In this case, Harsh, we want the negative value. So Vy final is negative 42.4382. And I can now put that on my triangle, negative 42.432. Now, on my triangle, to be honest, because I have an arrow pointing down, I don't need to put the negative in front of the number because the arrow includes the negative. That negative, okay? And here's what we're trying to find. This is V final right here. Yeah. Did I write it down wrong? How come that square and that square root doesn't cancel out? It's a bedmass thing. When you write it like this, technically, there's a big implied bracket there, which means you have to do what's inside the bracket before you move out one step of operations and do the square root. In fact, you can see on my calculator, as soon as I hit square root, it opens up a bracket to force me to remember that. So I can do it in one step on my calculator, but I know a lot of yours don't automatically open up a bracket. Some of you, when you hit square root, it does a little indent and it extends the square root line. What it's doing is it's implying the bracket for you. Okay. Hey, how can I figure out the magnitude of V final? Pythagoras. Remember I said the math here isn't tough, it's just lots of room to make mistakes. Pythagoras is math 8. I mean, it's yucky numbers here, Jordan, but this is math 8. Okay, so the magnitude of V final is going to be 43.301 squared plus 42.4382 squared, square root 60.6. That's the magnitude, that's the speed. Where's the theta going to go? Top left or bottom right? Color, 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 color. Vy, hey, that's opposite. Vx, hey, that's adjacent. Which trig function has an O and an A in it? I think tan equals opposite over. And you know what? There's a bit of a built-in error check here. Let me write this down first. 42.4, 43.3. Are those numbers fairly close to each other? This is almost an isosceles triangle. I'll bet you theta is going to be really close to 45 degrees. This is almost a 45-degree triangle. If the two sides were identical, I would know it was 45 and 45 degrees. So you're either going to get 44 point something or 46 point something. I don't know whether I'm above or below, but am I right when you do the shift tan or shift? Is it? Yeah? It's got to be. So that's neither here nor there, but it's a handy built-in error check. 42.4382 over 43.301. Do you get 44.4? What was your question? Say, would the 60.6 be negative? No, I'll show you how we'll work that. You're saying, but it's pointing down. Great question. Hold that thought. First of all, let's go at 44.4 degrees. Here's the answer to Owen's question. What of what? Well, if you said south of east, I would give you marks, but I would say, Owen, you know what? Up is not north and down is not east. We're looking at this from the side. So here's how we would describe this. Because we're looking at it from the side, our direction would be below the horizontal. That's how I would show on the way down. The first velocity that I gave you in the picture with that 30-degree angle, if I wrote that out in English, I would have said is being fired at a 30-degree angle above the horizontal. And then you would know, oh, up. Below the horizontal, down. If you say south of east, again, Davis, I wouldn't take marks off, but I'd give you a bit of a stink eye. Because my ceiling is not north, and the ground is not south. North is the back of my classroom. South is the front of my classroom. I'm going to ask you this question all the way up to and including part B on your test. I'm going to give you a cliff at an angle and ask you to find the range. You're going to have to do a quadratic, either on a solver or using the quadratic formula. I don't care. It's a lot of work for one question. But again, Davis, I would argue the math here, math, the most is math. Well, I guess quadratic formula is math 11, but otherwise, SOHCAHTOA is math 10. Pythagoras, I'm pretty sure you guys learned that in math 8 when you learned how to do square roots. Let's do another one. Example 2. Find the range. Percy, what does this question, example 2, want me to find? You know what I'm going to spend most of my time finding, though? Yeah. Okay. We have a cliff. We have an angle. Did I say angle? Components. I'm going to break this up into components. I'm going to make a T table and then see where I go. I suspect because they gave me a vertical displacement that I'm going to solve for time vertically. If they had given me a horizontal displacement, the range, I would solve for time horizontally, and that would be way easier because it's no longer a full quadratic equation. Anyways, here we go. Components. Vx, Vy initial. Hey Jack, Vy. Which trig function could I use to find Vy? Sine, you say. You know I'm coming back to you on that for a while with your sin. Man. So you're telling me that Vy initial is 35 sine 20, and Vx is going to be 35 cos 20. Here's my T table. I'll go to my calculator in a second, but what are my two physics no-brainers? Ax equals 0. Ay equals negative 9.8. I could have written that before I started. Now, Vx, let's see. 35 cos 20. 32.889. Vy initial. 35 sine 20. 11.9707. What else do I know? That 20, although it's not a 20. What am I going to write? Negative 20. Yep, I'm solving this vertically. I'm going to do the rest on my own quietly. You can look up if you get stuck. But try solving for t on your own, and then once you find t, find the range on your own. I'm going to use the quadratic formula. Hey, if you have a quadratic solver, feel free to use it. You'll beat me to the punchline. Okay. Those of you with your solvers, you get a time of around 3.5823 something something, and somewhere around there our decimals might diverge. 3.5824. Anybody else get that? Yeah, okay. I get these wrong too sometimes. There's just so much room to make silly mistakes. That's why I make these worth a lot of marks, so I can give you lots of part marks. Just keep going and follow through, and that way, if you get it wrong, you can still get 6 out of 7 or 5 out of 7 if you make a silly mistake. Leaving a negative off is one of the classic ones, as you were doing in that other question. Where at least there, the calculator gave you an error. Sometimes if you missed that negative, it'll still work and you won't get an error. You'll just get a completely different time value. I would give you 6 out of 7 for the question, probably. Okay. How many of you got that okay? Good. I can't say, hey, that's free marks on your test, but I'm telling you, if you master this, it's meticulous, earned free marks on your test. You got to earn it, but if you get the hang of it, you're good. Projectiles at angles from a cliff. Okay. I have read somewhere that there is an argument that this is why the first computers were invented during World War II. At that time, artillery gunners would radio the coordinates of the enemy back to headquarters, and headquarters would crunch all of this by hand to figure out what angle theta to send the artillery gun at to hit the target. But they knew, the enemy knew roughly how long it would take to do those calculations. And so if you knew that it would take about 10 minutes to do those calculations by hand, you just made sure you moved every 9 minutes and the targeting data was useless. Then when they invented the first computers, you could radio back to headquarters and you were getting a calculated answer in 30 seconds instead of 30 minutes, and it dramatically changed how artillery works. Learn trivia. Example 3. A projectile is launched from a 45-meter high cliff at an angle of 64 degrees with the horizontal, above the horizontal, with an initial velocity of 36 meters per second. A, find the range. Definitely going to dulp here. So what I mean is that the what 64-degree angle isn't going to go with a vertical line like that. The 64-degree angle is going to go from a horizontal line like that. So this is going to be 36 meters per second, 64 degrees, and this cliff height is 45 meters. Angeli, what does A want me to find? What am I really going to spend most of my time finding? Time. Sorry, let me give you the punchline a little easier. What am I going to spend most of my time finding? Time. Okay. So, triggers, components, angle, components, projectile T table. In fact, I could already do this without even reading the question. I could go, well, I know AX is 0, and I know AY is negative 9.8. Hey, Ange, which trig function is Vx going to be? Which trig function is Vy going to be? So Vx is going to be, of course it is. So if I was doing this in my homework, here's how I would cut corners a little bit. I would go, okay, Vx is going to be 36 cos 64. I might even go straight to my calculator if I was feeling particularly frisky. Vx is 15.781. Which trig function is Vy initial? Jack, which trig function is Vy? Good. So that's going to be, I have no idea, 32.357? If I round off properly. What else do I know? So Armand, we said that for these questions, T-table still, we're going to break into components. We came up with, we noticed a pattern. We noticed that Vy was always sine, and you might come up with a dumb way that you can remember that Vy is sine. And then we said, well, if Vy is sine, then of cos, Vx is cos, if you're looking for a stupid hack. Okay. That'll, by the way, that doesn't work for your airplane in a crosswind or river questions. It only works as long as you're getting an angle with a horizontal line. And for projectiles, I will always give you the angle with a horizontal line. So it's a shortcut we can use there. This 45, vertical or horizontal? Vertical, but it's not a 45. What's it going to be? Yeah. Question, yeah? What is Vy final? Please don't tell me it's 0. Please don't tell me it's 0. I'll snap. By the way, where would Vy final be 0? At the top. So what you would have done is you would have found time to top, which is probably not going to help you find the total flight time range. That one, by the way, I would probably take 2 marks off for that mistake, because that to me isn't a mistake. That's a fundamental conceptual error that I've been ranting and raving about since last year. Is that okay? Ange, which column do I know 3 things in? I'm finding it vertically. Good. Try this again on your own. I'll do it up here. Now I'm going to go quicker. You don't have to go this fast, but just to let you know, this can be done. Let me know if you got the same thing. Am I right? Yeah. The shortcut here, Grace, I didn't write out the quadratic formula. I've done it enough that I can actually go straight to plugging in the numbers. But even though I'm that good on a test or a quiz, I would probably still write it out just to make sure I have everything in the right place. I'm paranoid that way. Is that okay? Okay. So that there, totally fair game for the written section of a test. I've told you, I think, that I'm going to put one nasty multiple choice question. What would be fair game for that? Let's think about that. B would be fair game as a written. At what, turn the page. At what time does the projectile reach its maximum height, and how high is the maximum height? Okay. Manchan, since you had earlier said, isn't V final 0? No, V final at the top is going to be 0. We'll use that. What's this asking me to find in part B? Thank you for turning the page. Sorry, I should have, by the way, I should have paused. Everybody finish that? I didn't even ask. That was bad teaching. Anybody need more time there? Sorry. If you do, I'll scroll back later and you can copy it. Okay? What's B asking me to find?
dy.
Later, but what's it first asking me to find? Okay. Maximum height, does that suggest vertical or horizontal? Vertical. So I'm going to use Vy initial, which was 32.357. Mentioned, what's Vy final at the top? Yes. A equals negative 9.8. Hey, this is physics 11. We did a bunch like this. And it's nice, there's even a 0. I'm looking for an equation that's got a T, a Vi, a Vf, and an A in it. I shouldn't put a little Y there and a Y there, just to make sure I put verticals in. I think it's Vf equals Vi plus AT. Get the T by itself. T equals Vy final minus Vy initial all over AY. It's going to be 0 minus 32.357 all over negative 9.8. 0 minus 32.357 all over negative 9.8. Jack, did you get 3.3017, something like that? That's my way of saying, did you type it in, or are you following along, or are you zoning out? Okay, so pick up where we are at least. Okay, is it 3.30 seconds? Okay. And mention what was the second thing they wanted me to find? dy. Okay. Well, I'm looking for an equation that's got a... I think I can use this, can I not? VIT plus a half AT squared, and I can use my time answer. I could also use VF squared equals VI squared plus 2AD. I would avoid using my time answer, but no matter what, Emma, I'm using an answer that I calculated, the V initial, so I'm going to use the one that's got the D by itself already that I can just plug and chug, because, especially because I have time sitting in my answer button right now anyhow. So I can go like this. 32.357 T, answer button, plus 0.5 times negative 9.8 times answer button squared. $32.357 times answer button plus a half AT squared. Do y'all get 53.4? Yeah. Why is that wrong? No. I'll give you a hint. Why does the answer in the brackets there say 98.4 and not 53.4? We found how high we are above where we started from. Did we start on the ground? No. So the height is going to be dy plus the cliff. It's going to be 53.4 plus, how high was the cliff? 45? So we're 98.4 meters above the ground, which is where we measure stuff from. Okay. We're going to pause with part C. So I've been talking for a while. Okay. As a start, I'm going to assign more homework later, but for now, you can try number 1. Here's a bunch of cliffs at an angle. You can try number 6. You can try number 7. 8. So far I've assigned number 1, 6, 7. And by the way, the ones I'm avoiding are the ones that are asking you to find a velocity at some point along the way. We need to practice that a bit more, because that's asking you to find a slanty velocity at an angle. That I say angle, you have to find separate components in Pythagoras and tip to tail. That, yeah. Not yet. I'm not quite done yet. 1, 6, 7, 8, 9, and 10. But I'm not going to assign any questions from the ultimate review. These got some teeth and it'll take a while. Pause.